This question is about the constant accelerated motion of Mary and Sally. Both are in foot race, and when the Mary is 22 meters away and from the finish line, she has a speed of 4 meter per second. So it means that at the time t is equal to 0, if for example, if I assume that this is our rectangular coordinate system, this is our reference position, initial position. So Mary right now is at the origin and she has the speed 4 meter per second, whereas the Sally's speed is 5 meter per second. And Sally is 5 meter ahead of her. Now Sally thinks that she can easily win, so that's why she covers the remaining portion of the race with constant rate of this deceleration. Okay, so which means that Sally is decelerating. It means that Sally's speed will decrease because of this decreasing, slowing down. Whereas what about Mary? Mary is constantly accelerating, so Mary velocity time graph will look like this. Okay, so look at the last line. What acceleration does the Mary now need? Okay, if she wishes to cross the finish line side by side with Sally. Okay, so this last line give us clue that how you will tackle this problem, this question. Okay, so Mary also wished to reach this final point along with Sally. Okay, it means that one thing is same for both of them, that is a time of journey. So if you make two equations, you equate their times, you can also find out the acceleration very easily. So acceleration of Mary can be calculated if we equate the values of the time of Mary and the Sally. Okay, because they both reach the finish line at the same time. So for better understanding, let's deal both motions separately. When the Mary was here at the starting point, when her speed is 4 meter per second. Okay, so what is her initial position? So her initial position is 0 meter, and where she has to reach, she has to reach at this point, which is how much away it is. You know that according to the question, that is 22 meters. So we know the displacement, the total displacement covered by Mary, but we don't know what is her acceleration. Okay, and also we don't know the time. So if we apply the equation, kinematic equation, so delta x is equals to initial velocity along x-axis, the time, plus 1 over 2 a t square. Why we have applied this equation? Because we don't know what is the final velocity of Mary. Okay, that's why we have applied this equation. And in if we apply the values, then that is 22. Okay, means that x minus x0, that is equals to 22, is equals to what is initial velocity, that is 4 meter per second, time t, plus 1 over 2, acceleration is unknown, and the time square. Right, now in this equation we have two unknowns, so let's say this is equation 1. Let's talk about now Sally's motion. Okay, what about Sally? Sally is not at the reference point. Sally is already at some distance away from the reference, whereas the distance covered by Sally is how much? That must be 17 meter rightward. Okay, and what is the initial velocity of Sally? That is 5 meter per second. And we also know that Sally is decelerating. That's why we will take the value of her acceleration negative 0.40 meter per second square. Okay, so from by using this data, you can easily find out the time, that how much time she will take to reach the finish line. Okay, and then we will use that time in this equation to calculate acceleration needed. So the this is 22 meter is the total distance. So if we apply this equation, delta x is equals to vx0 t plus half at square axt square. So for Sally, right, it is x minus x0, right? Which is, you know, that 22 minus 5, which is 17 meter, because Sally has covered 17 meter of displacement, is equals to what is the velocity, initial velocity of Sally. So this is 5 into t plus 1 over 2 into negative 0.40 into t square. It will be negative 0.20 t square. So we see we got a quadratic equation, and by moving this 0.202 t square on the other side, it is positive, whereas 5t will become negative plus 17. Okay, you can also get rid of this 0.20 if you divide on both sides. So we will get, so 0.20, is 1 over 5. So it will become 5 multiplied by 5, that is 25t plus 85. Yes. So now you can factorize it if it is possible, or you can also apply quadratic formula. Anyways, the values of the time will be, so two possible values are 4.1 second and 21 second by solving this quadratic equation. Now we have to check quickly that which one of the possible value. Okay, so for example, if I put this 21 second, if I utilize this value to check its validity, okay, so I want to know when the Sally reached the final point, the finish point. Okay, I want to find out the Sally's final velocity. Okay, so initial velocity of Sally plus acceleration of Sally and the time taken t prime. Okay, for instance, I want to use this value 21 second. Okay, so it is 5 plus into negative 0.40 because she was decelerating into 21, and when you will solve it, it is negative 3.4 meter per second. Okay, now this negative value of velocity of Sally shows us that at the 21 second, Sally is not moving rightward, rather Sally may be turned back, and now Sally is moving in this direction. Okay, which is leftward. So it clearly shows us that it is not a required velocity. Okay, and that's why this is not a required time. Okay, so hence we will consider this time to be exactly relatable, because at this time the Sally will finish and Sally's velocity will be positive, showing us she is moving rightward. Okay, now we are going to use this value of time in this equation to find out acceleration. So let's plug the value here. Why we are plugging value? Because you remember we discussed that both are finishing the race at the same time, that's why. So if I multiply the whole equation with 2, so it will be 44 is equals to 8 into 8.1 plus a into 4.1 square. So this is 44 is equals to 64.8 into 16.81, and that will be 44. Sorry, that is 4.1, and when you will multiply it, it will be 32.8. And now you can take it on the other side, so negative 32.8 is equals to a into 16.81, and finally the value of acceleration is, so it is almost 0.67 meter per second square. So which means that Sally was actually accelerating, Mary was accelerating because its acceleration was positive, but Sally was decelerating. Thanks for watching, and subscribe this channel if you like this video. See you soon.